guys, we're on 7.2.2, how can I find the missing values? This is solving proportions, part 2. You have examined several proportional situations, such as the price of yogurt versus the number of pounds of yogurt, and non-proportional situations, such as the value of a college fund over time. Today, you will continue to develop strategies for solving proportional equations. So we're going to start with 7-106. Okay. JR reduced figure A at the right to create similar figure B, right? So we're looking at the original, and this is the new figure. So we scaled it. When we're talking about scale factor and scaling things, we're talking about enlarging or reducing the size of an image without changing up any of the angles or distorting it or anything like that, and it's all at the same ratio, the same rate. Okay, so part A, write down all of the ratios that compare the corresponding sides of figure B to figure A. Okay, so figure B to figure A. What is the relationship between these ratios? How do you know? So for part A, we're looking at B over A, the ratios. So if I look at the matching sides, here's 3 centimeters. The matching side would be 4 centimeters. So this one would be 3 over 4. Same thing, if I look at another side of this, here's 9 centimeters, the same corresponding side. So even if B was flipped upside down, you still want to match the sides. Okay, so that one would be 9 over 12, right? B to A. The other one, for the last part, we have X and we have 6 centimeters. So that one is going to be X over 6. What's the relationship between these ratios? They're all equal. 3/4, 9/12, X over 6, they're all going to be equal once you solve for X, right? So when we reduce the figure to create figure B while maintaining the similarity, so similar figures, it implies that each side is multiplied by the same scale factor. We have a multiplier that we're going from A to B, multiplying something, and that number that we use, that special number, the scale factor, is going to be the same for every single side that we do. If not, then the figures won't look the same. Okay? For part B, one of the relationships can be written as 3/4 equals X over 6. So let's write that down. 3/4 equals X over 6. Just a side note, the scale factor is the new over the old. So each one of these that we use, 3/4 or 9/12, when you reduce it, or when you simplify it, it'll still be the same fraction. All right. So one of the relationships between the sides can be written as 3/4 equals X over 6. Find 2 different ways to find the value of X in this equation. Is your answer reasonable? Okay, so first, finding a reasonable answer for X, for this number right here. If we look at this, going from 4 to 6, it's getting larger. So when we go from 3 to X, the number will be larger at the same time, the same rate. Is it going to be ridiculously large? No, because from 4 to 6, it's not that much of a jump. Okay, so let's look at some strategies that we've learned so far. One of them is to figure out what that multiplier is, right? So going from, this is in your toolkit notes as well, going from 4 to 6, right? What do we multiply by to go from 4 to 6? Now, if you don't know, then you just need to work backwards, right? So then you go, one way is multiplying, the other way, to go the opposite way, we divide. So what is 6 divided by 4? Right? When we do this, you will get 3/2 or 1.5, right? So going from 6 to 4, we divide. Going the other way, we multiply. So instead of dividing by 1.5, you have multiplying by 1.5, right? So if I do that to my denominator, I do it to my numerator, times 1.5, and that will give me X. So 3 times 1.5, this will give me X equals 4.5. Okay? And I'm going to spread this out for you guys so that you can see it, right? Let me rewrite it. So strategy number 1, we have 3/4 times, we found our multiplier. This is 1.5 in my numerator, 1.5 in my denominator. Oh, look, this is a big 1. And this will give me 4.5 over 6. So 6 was given, 4.5 is going to be my answer for that. Okay? Method number 2. Method number 2, when we look at this. So if I have 3/4, writing it again, equals x over 6, I'm going to eliminate the denominators. How do I do that? I can't just cross things out, right? I want to figure out, I want to isolate x. So how do I do that? What is near the x? There's that divided by 6. So how do I get rid of divided by 6? I do inverse operations, or the opposite. Instead of dividing by 6, I multiply it by 6. Whatever I do to one side, I have to do to the other. Multiply by 6 over there. On the right-hand side, this gives me my big 1. On the left-hand side, I just multiply straight out, right? So 6 times 3 will give us 18 over 4 in my denominator. When I simplify this, if I do 18 divided by 4, that will still give me the same answer of 4.5. Okay, so then we go back and we look to see if we need to label anything. My answer is going to be centimeters. Okay, so those are 2 different ways that you can solve. Are there other ways? Yeah, let me know what you think. That is 106. Next one. So JR's team is trying to find multiple ways to solve 3/4 equals x over 6 from problem 7-1 over 6, right? 106. With your team, analyze each of the strategies below. So we're going to go strategies one by one. Some of these strategies might be the same as what you came up with, however, others may be new. Work to understand each strategy so that you can use it to solve a new problem. JR wants to use a giant 1. Explain how he can find a value to use as a numerator and denominator in the giant 1. Then find the value of x. That is what we did. That was the first method that we did for this. So, to find the multiplier, if I look at this one, I didn't know what to multiply by, so I worked backwards and I divided. Right? So for part A, right, if you don't know how to multiply, what to go that way, then you go work backwards. You just divide. So 6 divided by 4 again is 1.5. This is the multiplier. Right? Just to clean it up, so 3/4 times 1.5 over 1.5. This will give us 4.5 over 6. Right? So that is centimeters. That's method A. Method B, looking at JR's work, Leticia said, I see it differently. We just need to find some number that when divided by 6, you get 3/4. Right? So looking at right here, some number divided by 6 gives you 3/4. We can undo the division by multiplying each side of the proportion by 6, which is what we did for the second one. Right? So are the 2 ratios still equal? Yes. So when we solve this, 3/4 equals 4.5 over 6. 3/4, when you divide, 3 divided by 4, what does this give you? This gives you 75/100. If I do the same thing, take 4.5 divided by 6, what does this give you? Also 75/100. Right? So that's how we know that our ratios are the same, that it's proportional, that these fractions are in fact equal, which is what we're trying to prove here. Okay, why did she choose to multiply by 6? That is because this is the denominator of the equation, right? We're trying to clear out our denominators to solve for x. Part C, Avner asks, if multiplying both sides by 6 gets rid of the denominator of x, then can we use the same strategy to get rid of the 4 in the other denominator? So we multiply both sides by 6. He's asking, can I multiply both sides by 4? Right? Like when we did for fraction busters. Can you do that? Yes, absolutely. So what they did, if you just look, we can just look at this one. 4 and 6 are our denominators. what did they multiply on both sides? 4 and 6, right? Here, when we simplify, just look, you don't have to write anything. So if I simplify, here's my big 1, 6 in the numerator, 6 in the denominator. Here is my big 1, 4 in the numerator, 4 in the denominator, and we see what's left. 6 and 3, right? X and 4. And that is what they bring down to the next line, okay? Does this help solve the equation? Yeah. It depends on which method you want to use. Sometimes it gives a difficult decimals to work with. In that case, then I would just be eliminating the denominators. Sometimes it's easier to just do method A, the first method of just finding the multiplier. So it depends on the situation. 108. Use the strategies from the previous problem to solve the problem below. Use Leticia's method of undoing division to solve this proportion. So for 7-108, let's rewrite the proportion. P over 22.5 is equal to 7 over 5, right? Undoing the division, okay? When you find P, replace the value in the original proportion to confirm that the two ratios are equal. So let's do this. Part A. Undoing the division. We have P. We want to solve for P. What is P being divided by, right? So this is only because it's being divided. If it was multiplied, you still do the inverse operation. You do the opposite, okay? So this says I want to find P by itself, right? What is near the P? It is dividing by 22.5. So to get rid of it, we do inverse operation. We do the opposite. Instead of dividing by 22.5, on both sides, we multiply by 22.5. Okay? Here creates the big 1, leaving us with P by itself. On the right hand, if I do 7 times 22.5, and then I just divide that by 5, this will give me 31.5. Okay? So when we solve this, we want to actually plug it into the original equation, see if that checks out, right? So substituting it back in, instead of P, 31.5 over 22.5 is equal to 7 over 5. Now, I'm just going to use my calculator. I'm going to divide 7 divided by 5. That was the fraction that they gave us. So this is what we want. We are going to check it with our solution, which was 31.5, and we got to see if that's correct. So 31.5 divided by 22.5, and that gives us 1 4/10. Is that equal? Yes. That is how you know you got the correct answer. Okay. Part B, write and solve in a proportional equation for x for the similar triangles at the right. Similar is very important, right? So you know it's the same ratio. Then use Abner's method of undoing both denominators. For B, I have these ratios, so it doesn't matter which one goes first, goes on top, but as long as you match it up. So I always want my x to be in my numerator. It makes it a lot easier. X over, and you're looking at that matching side. So here is my longest side right here. It's got to match up with that longest side right there. X over 30 is equal to, now I started with the smaller triangle, which means I need to start with the smaller triangle again. 12 over 15, matching sides, okay? So solving at the right, we're going to use the fraction busters, but first what I want to do is use it just an easier method, right? When I look at this, I see going towards x is what I want. Going from 15 to 30, all I have to do is multiply by 2. If I do it to my denominator, I do it to my numerator. There's my big 1. 12 times 2 is 24. Done. Okay. Let's do it the fraction buster method. X over 30 is equal to 12 over 15. Fraction busters, meaning we are getting rid of both fractions, so we need to get rid of both denominators. What are my two denominators? 30 and 15. So multiplying by 30 and 15 on both sides. All right. Here, on my left-hand side, 30 over 30 makes my big 1, and that leaves me with 15 and x. On the right-hand side, I have a big one with my 15 in my numerator, 15 in my denominator. This leaves me with 12 times 30. Okay, so 15x, just simplifying, equals 12 times 30 will give me 360. To solve for x, remember inverse operations, so what's near the x? It's 15. How do I get rid of the 15? This is multiplication, so I'm going to divide by 15 on both sides to get rid of it. Big one. 360 divided by 15. Hopefully it gives me the same answer, and it does. 24. Okay. So that's the fraction buster method. Part C, an apple juice container has a tiny hole in it, so it's slowly leaking. If the container leaks 3 ounces every 19 minutes, how long will it take for 16 of the ounces of the juice in the container to leak out? Write a proportional equation. Solve with JR's strategy of using a giant 1. Okay, so part C. Now we got a word problem that we have to figure out, right? So 3 ounces every 19 minutes. That is a rate, so we're going to write that down. 3 ounces for every, for every 19 minutes. On the other side of my fraction, the reason why we label, it's very important, is so we can match it up. How long will it take for 16 ounces? We're looking at 16 ounces for the container to leak out. How long? We don't know. That's our variable. Okay. So what we're looking for JR's method is the giant 1. What do we multiply? Both top and numerator and denominator to get 16. Now, I don't know what to multiply 3 times to get 16, so I'm going to work backwards. 16 divided by 3. When I do this, this gives me 5 and 3/10 repeating, right? So when I do this, this is now my multiplier. So when I do this, I can rewrite this as 3 over 19 equals, times my big 1, my multiplier, 5 and 3/10, repeating, equals 16 over some number. Now I'll double check. 3 times 5 and 3/10 repeating is 16. 19 times 5 and 3/10 repeating will give us 101 and 3/10 repeating minutes. Right, so 101 and about a third of a minute when we're looking at this. Okay, so there's a lot of methods there. Last one. Okay, for each problem below, decide if the situation is proportional. If the problem is proportional, say so. Then solve the problem using any strategy that you choose. If the problem is not proportional, explain why not, and then solve the problem. Okay, so go ahead, take a second and test these out for yourself, A through E, and then figure out if it's proportional or not. Part A, when we look at this one is proportional. So I'm going to put a P, proportional, okay? So Steve drove 130 miles in 2 hours. So 130 miles in 2 hours, right? If he continues to drive at the same speed is your rate. How long will it take him to drive 390 miles? 390 miles, and we don't know what our value is. For part B, so then you want to solve that. For part B, at an amusement park, you pay $15 entrance fee and then $4 for each ride you go on. How much will it cost you to go on 7 rides? Okay, this one is not proportional. Why? Because of this entrance fee. When you pay a one-time fee, right, a shipping charge, an entrance fee, one tax, right, that you do for just that one time, then it doesn't make it proportional anymore. Okay, but if that entrance fee wasn't there, it would be proportional. So how much will it cost you to go on 7 rides? The way I would write this out is $15 for the entrance fee, and you have $4 per ride, and there are 7 rides, and that's how you solve it. For C, I'll give the answers at the end. Armando collected 39 bottle caps in the past 3 months. At this rate, how many bottle caps would he have in 5 months? This is proportional, right? There's no one-time fee here. There's no extra bonus bottle cap that he got on the last day or anything like that. So 39 bottle caps in 3 months. We want to know how many bottle caps in 5 months. Go ahead and solve that proportion. For D, grocery store sells 3 limes for 99 cents. At this rate, how much would a dozen lime cost? Right? This one is going to be proportional. No extra fee, no sale price if you buy more than a dozen or anything like that. So 3 limes for 99 cents. We want to know how much will it cost for a dozen, we want to know how much will it cost. Cost is on the bottom, right? Because the money is on the bottom. How much would it be for a dozen? This is 12 limes. You have to know what a dozen is. E, Margaret drove her friends to a movie. She drove for 30 minutes at 10 miles per hour in heavy traffic. Then she drove for 15 minutes at 40 miles per hour. How far did she travel in those 45 minutes? Now, this is not proportional because it doesn't have the same rate. First, she was driving at 10 miles per hour, super slow. Then she was driving at 40 miles per hour. So how far did she travel? Right. If she looks at this, 30 minutes at 10 miles per hour, right? So then how many miles did she go for that one? And then 15 minutes at 40 miles per hour, how far she had to find the rate? 30 minutes at 10 miles. And then you have 15 minutes at 40 miles per hour. How far did she travel in those 45 minutes? Okay? Let me give you the answers. For A, answer. This is going to be 6 hours. You have a multiplier of 3. For part B, this will give you 28 plus 15. How much will it cost for 7 rides? This will give you $43, right? And then the not proportional part, remember we talked about a graph is proportional if it's a straight line, if it's got a constant rate, and it goes through 0, 0. Now, if you go to the amusement park and you don't go on any rides, that's your 0, but it still costs you $15 to get in, that's not 0, 0 anymore. Part C, how many bottle caps will you get in 5 months? This will be 65 bottle caps. Part D, how much would a dozen limes cost? How much would 12 limes cost? This will be $3.96. The last one, it's 10 miles per hour, right? So you're going for 30 minutes. There are 60 minutes in 1 hour. So you can use that proportion as well, right? 30 minutes would be half of an hour, so this would be 5 miles. 15 minutes is 1/4 of an hour, right? So this would be 10 miles, right? So 1/4 of the 40 miles per hour, and together this will be 15 miles total. Okay, if you have any questions, email me or comment in these sections and let us know. Okay, thank you.